Good morning, one and all. Today we discuss about the principle of superposition of waves. Going to this class, the last topic is speed of traveling waves. The speed of traveling waves, that is, with comparing one wave like this. Okay, this is displacement, this is position with varying time, that is displacement is function of position and time. That is the wave equation for progressive wave, that is A sin kx minus omega t plus phi. This is the displacement equation for progressive wave. Okay, this is A is the amplitude, that is A amplitude is nothing but this maximum displacement of the particle. Okay, that is, now we will discuss the speed of the wave. That is, suppose it is one wave. Suppose the two waves are traveling or moving to one place to another place. Suppose this is one wave, this is another wave. Okay, this is wave 1, this is wave 2. This is the variation, that is the displacement, that is displacement variation means the position will be changes. And also at this time t1, this t2, this t, this variation is t plus delta t. Okay, from this equation we can find the speed of the wave. V is equal to distance by time, that is change in distance means displacement or position, that is delta x by delta t. This is the speed of two waves are moving in the forward direction or x direction, that is slightly changes its position and time. The displacement is constant at amplitude is constant. Okay, this is the velocity speed of the wave. Now we will discuss about speed of the wave. V is equal to lambda by t or nu t. This is the speed of the traveling wave. And also we can find out the speed of the traveling wave in a stretched string, that is V is equal to the speed of the wave in the case of longitudinal, in the case of transverse wave, it is depends upon tension in the wire, and also it is velocity of the wave in the stretched string is also proportional to the linear mass density, is the tension. Okay, tension line in the case of wire, it can be stretched or forming a wave with tension is depends upon the velocity is depends upon tension in the wire, and also it is depends upon linear mass density. The linear mass density mu is equal to mass by length. Okay, different metals having different masses like brass, copper, bronze, aluminium, like this, etc. Now we can find the speed of the velocity from transverse wave, that is t by mu, under root of t by mu. And also we can find the speed of the velocity in the case of longitudinal, that is V is equal to E by rho. That means the velocity of the speed in the longitudinal is proportional to the elastic modulus, and also it is depends upon density of the material. Okay, that is the V of speed of the velocity in the longitudinal is proportional to the bulk modulus, elastic modulus by density. And also it is for bulk modulus, it is elastic modulus, bulk modulus B by rho. That is in the case of pressure P by rho. That is gamma or Y is by rho. It is elastic modulus, bulk modulus, Young modulus. Young modulus is proportional to the stress is proportional to strain. Stress is proportional to the strain. In the case of stretched wires, stretching wires, that means we can apply the force or pressure. We can apply in the changing the area. This can be changes elastic modulus changes with in area. It is beta. It is changes in volume. In length. In volume. It is Young modulus. It is changes in the length by delta L, V by delta V, A by delta V. This is the parameters of the speed of the Young modulus. And also finally we can conclude with speed of the wave in a longitudinal wave, that is, and also pressure and gamma by rho. It is the form of speed of longitudinal wave. And also finally the velocity of the speed of the wave is proportional to the under root of square root of temperature. This is the most, that is, it is depends upon speed of the velocity. It is depends upon temperature, root square of temperature. That means temperature increases, velocity of the particle or wave is increases. Now we will discuss principle of superposition of waves. What is the superposition? When two or more waves are traveling in a medium along the same direction, like this, one wave, another wave, another sub, like this. Okay, the superposition of two or more waves are combined or meet in a medium along the same direction, in the same direction as well as or opposite direction, like this. Okay, this is opposite, crust and tough, like this. Both are will be superposition when two or more waves are traveling in a medium along the same direction or opposite direction at meet at point. The resultant vector, the resultant wave is like this. Okay, that means two or more are the direction in the same direction, then the resultant displacement is algebraic sum of the displacement due to each pulse. This is 1 second, 1 2 3, like this. 2 pulse gives the resultant displacement. So like this, see, one wave is like this, another wave is like this. Superposition of two waves, we can form a, that is, particle or atom is vibrating, passing through the particle. This can be vibrating at large displacement. That means it can be having large amplitude. That is, displacement is higher. Displacement is maximum is nothing but amplitude. We get the resultant of two vectors. This vector, wave 1, wave 2. Two waves are superposition. We can get the resultant displacement is like this. Suppose this is a C. Okay, suppose this is the displacement is y1, this displacement is y2. The resultant vector is y is equal to y1 plus y2. We can comparing the only two waves. Suppose we can choosing the number of waves. We can y is equal to y1 plus y2 plus y3 plus y2 up to yn. We can choosing the number of waves or superposition we get the resultant vector, resultant wave like this. Suppose we can choosing like the two, or only two can choosing the two waves are a superposition. The resultant vector is like this. You can, that means this phase crust and crust can be form. We can get the, suppose see here, this crust is 1 centimeter, this crust can be 1 centimeter, 1 plus 1, this amplitude is 2 centimeter like this, and also same is minus 2 centimeter like this. That means some of the input like this, input is output, the resultant displacement you get highest amplitude or displacement of the resultant vector. Now the resultant vector like this, two are waves are, first wave is displacement of the first wave is a sin kx minus omega t. Okay, and also y2 is second wave, displacement of this second wave is a sin kx minus omega t phi. This is equation number 1. Equation number 2, the resultant vector, the resultant displacement is y is equal to y1 plus y2. That is like this, the resultant displacement is like this, y1 plus y2. There is the y2 the red, I will write y is equal to y1 plus y2 is equal to what? Y1 is equal to a sin omega t, kx minus omega t plus omega t only. Next y2 is equal to a sin omega kx minus omega t plus phi. Okay, okay, this is in the form of sin a plus b plus sin a minus b form. This is a plus a minus b, a plus b. This is a plus b, this is sin a sin b, sin a plus sin b formula is equal to 2 sin a plus b by 2 cos a minus b by 2. This is a sin a plus sin a sin b formula, 2 sin a plus b by 2 cos a by a minus b by 2. Now we will discuss. Okay, that is, this equation can be written as y is equal to a sin kx minus omega t plus a sin kx minus omega t plus phi. This is sin a, this is sin a sin b. Okay, we can simplify, we get y is equal to a is common to sin 2 kx minus omega t plus phi. This is a, this is b, a by 2 cos b by 2. This is a cancel. Okay, after simplifying this one. Okay, this is the equation simplify, that is a 2a cos pi by 2 into a sin kx minus omega t plus pi by 2. This is the wave equation. This is the wave equation. This is the amplitude displacement of the two waves are superposition. The resultant displacement is like this, y is equal to 2 a cos pi by 2 sin kx minus omega t plus pi by 2. This is the resultant displacement of the two waves. This term is the amplitude. Comparing like this, y is equal to a sin kx minus omega t plus pi by 2. Comparing both equations, this is a is equal to 2 cos pi by 2. Okay, 2 cos pi by 2. This is the amplitude of the two waves, or superposition of the resultant superposition of the two waves. Okay, if amplitude a is equal to 2a cos pi by 2, okay, we can apply. If pi is equal to 0, they can apply a is equal to amplitude 2a cos pi by 2. That means pi 0 means 2a into cos 0 1, that is 2a. That is maximum amplitude. The maximum amplitude means, see here, there is first wave, second wave, the resultant vector, that is crust and crust are coming superposition, we get highest amplitude. That means suppose 1 centimeter or 2 centimeter, get 4 centimeter of amplitude of the resultant wave. That is if phi is equal to 0, that means form a crust and crust will be formed, like crust and crust get highest amplitude. Crust and crust are superposition, we get the resultant vector like this. This case, when it is occurring, when the two waves are in phase. In phase means same phase, is in the same phase. Okay, this is a crust and crust is a phase. This is both will be same phase. That is same phase means the phase difference is 0. Phase difference is 0 or 2 pi or 4 pi or n pi. This is when phase difference is 0, the waves are in phase, or same in phase, like this. Both will be in phase. Out of phase means like this. In phase means like this. Okay, the resultant displacement is like this. When will it is appearing means bright case. In the case of interference, we get the bright fringes. That is this is the condition for constructive superposition for interference. Constructive interference means when it is occurring means we get maximum amplitude, and that is the maximum amplitude means brightness. Maximum amplitude or intensity, highest intensity. Brightness is nothing but highest, amplitude is nothing but highest intensity or highest amplitude. In the case of constructive case, that is a constructive superposition interference. When if phi is equal to, if pi phase difference is 0.3 pi 5 pi 2n plus 1, the waves are in out of phase. Out of phase means like this. Trough and crust and trough, like this. Both will be cancelling. We get the straight line or dark ring. We get the dark like this. Here this is the wave 1, is another wave 1. In between them the phase difference is pi. Okay, that is this wave superposition with this wave form a resultant displacement is 0, because the here displacement is amplitude is +1 minus 1. In this case amplitude is in this case amplitude is plus a. this case is minus a is equal to 0. The resultant amplitude is 0. The resultant amplitude is nothing but displacement is 0. We get dark ring, the dark ring interference. This type of condition is destructive superposition of interference. That means we get the crust and trough can be formed, and superposition we get the resultant displacement is 0 or resultant amplitude is 0. That is vanishes, that is straight line will be come. Okay, it is not possible to occur a wave. Okay, see here, two waves are coming through the particle after before collision. Single waves, after superposition we get the amplitude is hybrid. That means the particle is vibrating like this. Two waves are forming, the resultant amplitude is a plus a1. Suppose it is for crust, the crust is a1. It is suppose like this, here a1 plus a2 from crust. For this one, for 2 minus a1 plus a2. Here a1 minus a1 minus a1, that is 0. The resultant amplitude or displacement is 0. In the case of phase difference is out of phase. Okay, in the case of see in when after certain time the pulse can be changes with the time. Suppose two pulse is like this, 2 cm, it comes, this pulse are right side, both will be superposition from a resultant wave like this. And also after collision the waves are separated with like this. And also same, this crust and crust can be from a highest amplitude. Okay, next crust and trough, after certain time it can be certain time it comes to closer, and also the resultant displacement or amplitude is 0. After certain after superposition the pulse are separated like this. It is clockwise, it is first is upward, it is mirror image, like mirror image. Thank you, one and all. Now we can explain the problems. The second problem is a steel wire is 0.72 mass long, has a mass 5 into 10 to the power minus 3 kgs. If the wire is under tension, the tension is 16 newtons. What is the speed of transverse wave of wire? Okay, in the first problem, see here L is given, mass is given, tension is given. You find the velocity of the wave, that is mu is linear density is equal to mass by we can find the speed of light, speed of the transverse wave, transverse wave. Okay, transverse wave is t by under root of mu. This is the equation. You know t, we can find the mu. Mu is equal to mass by length. Mass is given, length is given. You can find the linear density. The linear speed of the wire is v is equal to t by mu. We can substitute these values, we get the 93 meter per second. And also the second problem is there. To estimate the speed of sound in air at a standard temperature, STP, standard temperature pressure. STP means standard temperature and pressure. The mass of 1 mole in air is mass of mole is 29 into 10 to the power minus 3 kgs. Okay, now we can find the speed of the wave. Okay, suppose you know speed of the wave is y, young modulus by rho. This is the equation, okay, which is given. In the case of it is STP, the molecule having gas having occupied mass is 22.4 liters at STP, standard temperature and pressure. Okay, the rho is equal to mass in air by volume of in air. Okay, there is mass is given 29 into 10 power minus kgs. The volume of the atom mole is 22.4. It is constant. We get density of gases. Okay, we can find the mass volume of velocity of the gases at STP. Here this is the constant Young modulus by density. Young modulus value is 1.1 into 10 to the power of 5 Newton per meter square. Okay, the density of the gas is 1.29 kg per meter cube. We can get under root of we get the 280 meter per second. This is in the gas molecule at STP. Thank you, one and all.